In this discussion, we are going to look at interpolation. So still we are moving under numerical methods, and interpolation is one of the uh, tools that we use in numerical methods to estimate values, okay, and known values of a function for given points. Okay, you can be given that the function has a value at this value of x, it has a value of x equivalent to this. Then, in between them or outside those points, they ask you what is the value of the function at x is equal to this. Then you can carry out the interpolation basing on the method that you have been recommended to use. You will be able to determine the values of the function. So we are saying this is especially useful when we have a discrete set of data points and want to estimate the function's value at a point where it has not been explicitly provided. Like I'm saying, they can tell you that this is maybe x and this is f of x. Okay, they say at x is equal to 1, the value of the function is 0.5. They tell you at x is equal to 3, the value of the function is 0.8. Then they tell you they want the value of the function at x is equal to 2. So you'll just let it be that maybe f of 2. Okay, this can be f of 2. Then you utilize, if it is linear interpolation, then you can say maybe this minus that divided by this over this. For example, I can say 1 minus 3 divided by 0.5 minus 0.8 is going to be 2 minus 3 divided by f of 2 minus 0.8. I cross multiply and then make f of 2 the subject of the formula, and I'll be able to get the value of f of 2. Okay, that is what we call interpolation. So there are a number of methods that we use. Okay, there are a number of methods that we use, and one of them is linear interpolation, which we have just demonstrated up there. Then we have the polynomial interpolation, spline interpolation, Langrange interpolation, Newton's divided differences interpolation. For this course, I may talk about Lagrange, okay? We will talk about Lagrange and linear interpolation. The polynomial is going to use also Lagrange somewhere, somehow. So, can look at even this. So linear interpolation, we assume that the function between the two known points is a straight line and is the simplest form of interpolation, like we have demonstrated up there. And therefore, you can see it's giving us a formula. So let us see which is giving us a value of that. So we could be having at x naught, the value of the function is f x naught. At x1, the value of the function is fx1. At x, the value of the function, okay, is f of x. So if this is unknown, okay, let us assume that this one is unknown. it is unknown, I can say x1, if I try to take, maybe if this x1 is bigger than x0, let me say this is going to be x1 minus x0, okay, divided by fx1 minus fx0. This is going to be, I'm assuming also that x is bigger than x1, so I will have x minus x1 divided by f of x minus f of x1. So what I do, I cross multiply. If I cross multiply, I can bring this here, this there, okay? And then I manipulate this other value. So I bring f of x minus f of x1 this side. Then I bring this here so that I have this equal to x minus x1 divided by x1 minus x0. This is equal to, okay? So then this other one is fx1 into fx1 minus fx0, okay? Now, what is, this is, okay, whichever. This is x1. So I can say my f of x will equal to this value plus fx1. This is what I'm following. So fx will be x minus x1 divided by x1 minus x0, okay, into f of x1 minus f of x0, then plus f of x1. So that will give us the approximate value of f of x if I interpolate between the given values of x and given values of the function. Because x1 and x1, x0, x are known, and therefore the values of x0 and then fx0, fx1 are also known. And what is not known is just fx, and therefore can obtain it. So if at all you're given such a problem, if we want to estimate f of 3, we just use the above equation and substitute in here. So this would give you that you said you have x0, you have x1. So x0 is equal to 1, just for demonstration purposes. X0 is equal to 1, x1 is equal to 4, and fx0 is therefore equal to 2, and fx1 is equal to 5. So we are looking for fx at x is equal to 3. So can use that formula and get those values. The next one is polynomial interpolation. Is used to approximate the function between data points. The most common form is using Langrange interpolation or Newton's divided difference interpolation. Like I said, we can use Lagrange to get to do what we call polynomial interpolation between different points of a polynomial. And remember, a polynomial is not linear, it's non-linear. It can be x cubed, it can be x to the power 4, it can be x squared, and so on and so forth. Therefore, you can interpolate between the different points of such a function. When given those points, you can use the Lagrange interpolation. Then the spline uses a piece word polynomials to interpolate between data points. The most commonly used splines are cubic splines. This one we shall not dwell much on it. So let's look at the Lagrange. So we have the Lagrange, and is a polynomial interpolation method where a polynomial is constructed such a way that it passes through all given points. So if you are looking at the Lagrange polynomial for any data points, then the Lagrange function will be, or the Lagrange polynomial interpolation will be sum of y1, then you get a multiples. Of x minus xj out of xi minus xj from j is equal to 0, and we multiply only values where j is not equal to I. In other words, if we are looking at the Lagrange of, for example, Li, or the basis of the Lagrange, and we are talking about Li of x, then in getting that Li of x, where we find that we have I equal to j, I and j are just indexes or indices. Like if I have x naught, y naught, okay, I have x1, y1, I have x2, y2. Here we are meaning the indices is going to be for example, this one is going to be I, which is equal to 0. This is going to be I, which is equal to 2. This is going to be I is equal to 1. Then the j takes all. J is equal to 0, j is equal to 2, j is equal to 1. But where we find that j is equal to I, then that function or that multiple is going to be 0. Anyway, let me go through it here so that you can understand. So we are saying the I and the j are indices, as I said. This is the construction of the Lagrange basis polynomials used to form the overall interpolation. So we are using the Lagrange interpolation formula is this, and we are told that the yi is the known function. That is the function values at the given data points. For example, you can be given that f of 2 is 7, but that means our value of x is equal to 2. So it may depend. This could be maybe x1, okay? Could be x1 or x0. So, and that x0, let me say, okay, if I take x1, then that means I will have x1 equal to y1. So if I'm looking for yi, this is going to be the value of the function at known x value. If I'm looking for f of x2, this is going to give me y2. If I'm looking for x0, f of x0, this is going to be giving me y0, as you can see it. And then just note this one, I will not ask you to answer it in an exam, but just for knowledge. So the Li are the Lagrange basis polynomials for each I. Let's look at how they can be constructed. So the Li gives you a multiple. That's the basis Lagrange polynomial. Is going to give you multiples of x minus xj out of xi minus xj. So what if I'm looking for L1? Okay, that is I is equal to 1. or I is equal to 0 for error node. So if it is 1, then this is going to be x minus. This is going to be like x into, okay, let me say x naught divided by this. So where I is equal to j, you ignore that. So this can be x, for example, x1, then minus, okay, minus x, okay, this can be x naught. Okay, then you proceed. Put the other multiple, which can be x minus x1. Okay, this must never be the same. So minus x2 divided by, this can be x1 minus x2. So we're going to see how you can construct that basis, the Lagrange basis polynomial. There we are seeing y, I, and j are there. So if we have 3 data points like x naught, y naught, so the error node would be x minus x1 into x minus x2, like we earlier on said. Then divided by x naught minus x1 and x naught minus x2. So that will be the basis, the Lagrange basis polynomial for x naught. If we are talking about for x1, then it will be like this. The I and j must never be the same. If they are the same, then it will equal to 0. That's why here, if this j is 0, the I is 1. If j is 2, okay, I is 1. So they can never be the same. Then the Lagrange basis polynomial for x2 is also. So how you apply it and get the approximate interpolation using Lagrange, you end up getting a function that interpolates very well between these points. Then the Newton's divided difference is like that, but as I said, we shall not emphasize it. So the applications of this interpolation is that interpolation helps us to estimate data at unmeasured points in fields like economics, engineering, and meteorology. Then image resizing in computer graphics. We use interpolation to resize. Then we also use it in signal processing. So we use interpolation to reconstruct signals from sampled data points. So those who will be in electrical, those who are doing electrical engineering, they do more of signal processing. So this kind of interpolation, when you proceed at an advanced stage, you can be able to reconstruct signals from sampled data points.